derivatives of logarithmic functions. Okay, so let's carry on. This is what's going to be similar to derivatives of exponential functions. Okay, so if we want to find the derivative of y is equal to the natural log of x, then what we can do is let's convert that into exponential form and then figure out the derivative using implicit differentiation. Okay, so first off, let's write it down again. Y is equal to the natural log of x. Just as a little bit of a review here, this would be the same thing as y is equal to log base e of x, right? That means the same thing, right? So if you're going to convert that into exponential form, then remember how this works. It's really saying like e to the power of y is equal to x. Okay, remember like logs solve for exponents. So this would be the same thing as writing e to the power of y is equal to x. Those mean the same thing. Okay. So then from there, let's derive this. So the derivative of e to the power of y would be e to the power of y from the last lesson there, right? And then we have to remember to multiply by the inside, right? So we still have to multiply by y prime. And then the derivative of x is equal to 1. Okay, so then we'll just get y prime on its own. So we get y prime is equal to 1 over e to the y. E to the y. Now, that's not that helpful because I really want it in terms of x. And turns out you kind of can, right? E to the power of y is just equal to x. So let's just write this one more time. It's y prime is equal to just 1 over x. Well, that's not too bad. So there's our rule for the derivative of the natural log. It's just equal to 1 over x. So that's not even much worse than the last one, right? Okay, so now remember, as we're doing this again, like always, whenever we take derivatives, we just always have to take into account the chain rule. Okay, so in general, if we have some function, the natural log of g of x, then that would be 1 over g of x, and then times g prime of x, the derivative of g of x. So, or more simply, you can write it like this as well, g prime of x over g of x. Okay, so let's jump into some. So differentiate each of the following. Okay, well, we have to do these in order, right? So to begin with, so y prime, I have to deal with the exponent. So just for a second, pretend that that's just x in the middle there, right? So this is, just bring down the 4, so 4 times, and then just leave whatever's inside. So that's still just the natural log of x, and then to the power of 3. And then now I'm taking the derivative of the inside. So the derivative of the natural log of x is just 1 over x. So then that's just 4 times the natural log of x cubed all over x. Okay. Now, this one looks the same, but it's not, right? Where the brackets were matter, because like notice in this one, we had to do the chain, we had to chain rule the 4 down first, right? And then take the derivative of the natural log. Now in this case, there's no brackets here, but there really are. There's actually implied brackets right there, right? We're taking the natural log of x to the power of 4. So we need to do the natural log part of this thing first, and then it'll be the x to the power of 4 will be our inside of our chain rule. So the derivative, so f prime of x is equal to, so then the derivative of that would just be 1 over x to the power of 4, okay? And then times the derivative of the inside. So then this would be just 4x to the 3. So then x to the 3 would cancel with everything but one of those x's down there. So we just get 4 over x. Now, while we're on this, I'm kind of jumping ahead a little bit, but we could have done this a little bit different too. If you remember with our log laws, do you remember that one where if we have log of some value to the power of 4 in this case, do you remember how we could just bring that guy down front? So right off the bat, we could have wrote this as f of x is equal to 4 times the natural log of x. Okay, and then that would just be, so the derivative would just be 4 times, and then the natural log of x would be 1 over x. So we get the same thing, 4 over x. So both methods work. This one might be easier once we start getting used to our log laws again. Okay, next one. So y prime is equal to, okay, the derivative of the natural log is 1 over. So 1 over sine x in this case. And then the derivative of the inside would be cos. So this is equal to cos x over sine x, also known as cotan x. All right, so now we got to do this one by implicit differentiation because we have y's on either side, right? It's not nice and neat for me. So derivative of natural log of xy, first off, would just be 1 over xy, okay? And then times the inside, and now the inside here, this is a product rule, right? There's my f and there's my g. So this would be x times y prime plus 1 times y. And then that's equal to 24 y squared, and then times y prime. Okay, now I'm going to write this all over a common denominator here. So just same thing, I'm just going to write a little different. This would be x y prime plus y over xy is equal to 24 y squared y prime. Now I just did that so that I didn't even really need to do that step. Now I'm just going to move this one up to this side. So we've got xy prime plus y is equal to 24y cubed now, right? Y times that y squared, so y cubed. And there's also an x in there now. We'll put the x first. So xy cubed, and then there's also the y prime. Okay, now we want to get our y primes on the same side, so I'll move this chunk over to the right. So we've got y is equal to 24 x y cubed y prime minus x y prime. And then now I can factor out my y prime. So we've got y is equal to, and then y prime, and then you're left with 24 x times y cubed minus x. And then just divide both sides by that, so we get y over 24 x y cubed minus x is equal to y prime. Okay, so I gave an example of problems like this actually before too, or just like kind of a preview of it. So now in these style ones, we're going to see that it's actually going to be a lot easier if we break things up using log laws to begin with, and then take the derivative. It would work either way, but this one would be kind of messy, right? You'd have to take the derivative of natural log, and it'd be 1 over that, and then you'd have to do the quotient rule of the inside. We can just make this a lot easier, and if you remember your laws of logarithms, the natural log of, and then we have some argument where, come on, all right. So it's this function divided by this function. Well, we can separate that out as a subtraction. So this would be the same thing as f of x is equal to the natural log of x squared plus 1 minus the natural log of x plus 1. And there you go. That's going to be a lot nicer to work with. So now let's take the derivative. So this would be f prime of x is equal to step number 1, the natural log, or the derivative of the natural log is 1 over the argument. So 1 over x squared plus 1. And then times the derivative of the inside. Chain rule here. So 2x minus And then similar thing going on here, right? 1 over x plus 1, and then times the derivative of the inside would just be 1 in this case. Okay, let's clean that up. So we've got 2x over x squared plus 1 minus 1 over x plus 1. Now we should put this all over a common denominator. So I'm going to multiply this side by x plus 1, top and bottom, and this side by x squared plus 1. Okay, so then if you expand that out, we get 2x squared plus 2x minus x squared. And then remember when you put this in, right, we're subtracting this. So minus x squared and then minus 1, right, not plus anymore. Okay. Okay, and then that's all over our common denominator now. So that'd be x squared plus 1 times x plus 1. Okay, and then just collecting our x squared like terms. So that's x squared plus 2x minus 1 all over x squared plus 1 x plus 1. Okay, so in this one, let's use some exponent laws again, or some log laws, I mean. So we'll write this out as the natural log of, and I'm going to split them up right here, because this is being multiplied, those two terms. Okay, so natural log of, and instead of the square root, let's write this as 8x and then to the power of a half. Okay, and then this would be plus, right, because we're multiplying, so log laws we would add. So this would be the natural log of tan x, and again I'm going to write it like this, tan x squared. And the reason why I did that is because now we can do some more log laws. Let's actually bring the exponents down, right? So this would be y is equal to, and I get to just bring that one down front, right? That's just 1/2 times the natural log of 8x. And then this would be 2 times the natural log of tan. All right, so now we'll say y prime. So the 1/2 just gets to hang out, times, and then this would be 1 over 8x, and then times the derivative of the inside, so that would just still be 8. So if you like, we can cancel that now if we want. Okay, and then moving on, so then we have 2 times, and then this would be 1 over tan x, and then times the derivative of tan x, so secant squared x. Now let's write this out to see if there's anything that we can cancel here, right? So far this first one simplified out nicely, that's 1 over 2x plus, and then this would be 2 times, and then 1 over tan, that's just really cotan, so that would be same thing as cos x over sine x times, and then this would be 1 over cos squared x. Okay, meaning that we can cancel one of our coses. So y prime is equal to, let's just see what we have going on here now, 2x plus, and then that's just 2 over sine x cos x. Okay, so then that really is it. So let's just write it over a common denominator now. Okay, so let's multiply this side by sine x cos x, top and bottom. Okay, and then the other one would be 2x, top and bottom. All right, so we get sine x cos x plus 4x all over our common denominator of 2x times sine x cos x. And there you go. Oop. Okay, number 3. Find the equation of the tangent line to the function y is equal to the natural log of x over x at the point where x is equal to e squared. Okay, so use the quotient rule here. So we've got f and g. And yeah, let's maybe back up. What we want to do here, like other questions like this, you guys have done this quite a few times now, we want to find the derivative of this point, because that's going to tell us in the equation y is equal to mx plus b. We can the derivative is going to tell us at that point, we can figure out what the slope is right there, right? And then from there, we can also figure out if x is e squared, we'll be able to figure out y, and then figure out what b is, or use that point. So step number 1, let's find the derivative. So y prime is equal to, that would be x times 1 over x, where x was our g, and 1 over x, that was our f prime, minus, and then the natural log of x times 1, where the natural log of x was f prime, and then, f, and then g prime was 1, all over x squared. Okay, so y prime is equal to, so in this case, this is x over x, this is just 1, minus the natural log of x, all over x squared. So there you go, that really is our derivative. So that's our general function for the derivative of this. So now let's actually just throw our point in. So the slope would be equal to, well, the slope is going to be when we have a point, like an x value of e squared. So let's throw in e squared for that. So we've got 1 minus the natural log of e squared all over e squared to the power of 2. So now this would be 1 minus, now the natural log of e to the power of 2, you can think about it this way, right? We use our log laws to bring the 2 down front, then that's just 2 times the natural log of e, and the natural log of e is just 1, right? So this is just 2 over e to the power of 4. So our slope is just -1 over e to the 4. So then the next piece that we're going to need is to figure out what y is. So y at x is equal to e to the 4. So let's find the y value there. So then y would be equal to, and then just plugging into the original function. So the natural log of, and instead of an x, it's going to be, e to the power of 2. 2. Okay. So then natural log of e to the power of 2 over, and then e to the power of 2. So then this would be y is equal to, actually I'll save space here, y is equal to 2 over e squared. Okay, so I think we're ready to plug it all in. So we've got, let's do it in point slope form. So y minus y1 is equal to m x minus x1. So then y minus, and then y1, that's what we just found. So that'd be y minus 2 over e squared is equal to -1 over e to the 4, right? That's our slope from before, times x minus, and then this was e squared. Now, that is the equation now. Like, we have it to that point. But what I want to do is, I don't really like the exponents, or I don't really like the denominators here, right? So why don't we clear the denominators by multiplying everything by e to the power of 4. Okay, so that's going to clear out anything I have left down there. So then what you'd have left would be e to the 4 times y minus, and then e to the 4 over e to the 2. I now have 2e to the 2 is equal to, and then e to the 4 cancels with e to the 4, so now we've got minus x, and then plus e to the 6. So hopefully I didn't lose you there. I went e to the 4 times e to the 2 was e to the 6, and then over e to the 4 was e to the 2, right? So it kind of expanded this part in, right, without actually doing it there. So hopefully I didn't lose you. If you want, expand that out first and then apply the e to the 4. Okay, and then rearranging this, we get 0 is equal to x plus e to the 4y minus 3 e squared. So this is our formula written in standard form. Okay, so now moving on to other logarithms. Let's find the derivative of y is equal to log base 2 of x by using the change of base rule. Okay, so the change of base rule, to remind ourselves here, is log base b of c is equal to log base a of c over log base a of b, right? So then we can change this to, well, in this case, let's change it to e, right? Let's do the natural log. So this would be log base 2 of x would be equal to log base e of x over log base e of 2, right? So then let's just write that as we know it, right? That log base e is really the natural log of x over the natural log of 2. Okay, so then what this means is that y is equal to this, really, right? And for a second, I'm just going to write this a little different. Let's call this 1 over the natural log of 2 times the natural log of x. Just kind of separating it out there, right? So now let's take the derivative of this. Okay, so this would be, so y prime would be 1 over the natural log of 2 times, and then 1 over x. So 1 over x times the natural log of 2. Okay, perfect. So that's probably enough to make a rule here. So we can say the natural log of b to the power of x is really just 1 over x times the natural log of b, right? Like in that case it was 2, but it could just be any number. Okay, so let's differentiate this one. So first off, let's make life easy on ourselves and use log laws to bring that 5 down front. So this would be f of x is equal to 5 times log 3x plus 1. Okay, so f prime of x is equal to 5 times, and then we're looking back up here again, right? So 1 over x. So what was x? Well, in this case, x was 3x plus 1. So 3x plus 1 times, right? And now I'm looking at the next part, the natural log of b. Okay, so what was b in this example? So remember, it was written log, and then what's the base? Well, if there's nothing written there, it's really base 10, right? So this would be 1 over the natural log of 10. And then don't forget, this would be an easy thing to forget, now that we've taken the derivative of this, right, the whole thing, we still have to chain rule it. You still have to multiply by the derivative of the inside, so that'd be 3. Okay, putting this all together, we get 15 over 3x plus 1 times the natural log of 10.